Hi, I'm Alan Willard. I'm a developer relations technical artist at Epic Games, and today I'm going to be demonstrating and talking about how I built this. I just called it Silly Geo for lack of anything better, but it's essentially a really simple twin stick shooter. It lets you drive your ship around, fire at enemies, switch weapons. It's got a few waves built in. It's not a multiplayer game. It doesn't have multiple rounds or anything. It's just got a very simple mechanism to track how many enemies you've killed, advance waves, and then tell you if you've won or lost at the end. So I did this about a month and a half, 2 months ago. So I may have a few things that I don't actually remember how I did, which I'll live. So I'm going to actually look at the level. So the first thing you're going to see is I made a grid material. Now this is a translucent grid. I just put two of them above one another so that you'd have a little bit of a parallax feel to give the world a little depth. And then I built this really simple modular set of walls. There's no complex behavior here. I literally just dropped them in place, moved them around. I made a couple of materials that let me change color so that you could have different shapes, different appearances. The whole thing I wanted to do with this was make sure that as much as possible the assets that I used were from the starter content. So really simple shapes, reusing a bunch of the same thing in a lot of ways. And since I am the one who originally built a lot of that starter content, I actually knew what a lot of it was and where to find it. The next thing I did was drop in blocking volumes. This is to make sure that the entire perimeter of the level had collision, so that when I put my navigation mesh in, I would get a really nice fit to my level. So I'm not using the navigation for navigation of the enemies. I'm actually using it as kind of a guideline for where I can spawn enemies. So it's more like a valid bounds of the world than the actual AI behavior beyond where to spawn. The next thing I started working on was the player. So rather than break it all down and hope that everybody remembers it, I'll go ahead and play it really quick. So here's myself as a player. In this mode, the WASD keys will let me fly around. I've got a number of creatures that have spawned and are chasing me down. Mouse wheel will change the current weapon, and everything's color-coded. If I shoot a red enemy with a yellow weapon, nothing will happen. It'll impact and bounce off, but nothing's going to actually decrement the number of enemies in my scene. So you have to match the color of the current enemy, whittle them down to none left in the current wave, and then it'll start the next wave. And the waves all have different colors of enemies. So the second wave has blue and yellow. The third has red and green, I think. You can tell I'm really really well practiced on what my own little mini game here does. Yes, thank you for laughing. Yeah, so red and green, and each of the enemies, they're all based off of the same base enemy blueprint that I created. So I treat that as a parent class, and then I can override individual behaviors for each subgenre of enemy. And there I've one. So jumping back up, the first thing I built was my player, and he took a little while to build correctly. So I've got my player controller, and this is where I do things like if he dies because you've been hit by enough enemies, I turn off input. Here I'm taking input from, in this case it's the left stick, and if this is moving, I add that to the movement input for the player. So this way I have one stick, or in this case the WASD keys, are driving the movement but not rotation or anything of the player. So this is sliding the player around. Now the player is set up to be on a plane. You can see here I'm also looking at the different elements of the graph. There's very little setup in the controller. All I really wanted was the rough course movement of the player to be driven here. And then going into the player himself, here's where some of the more complex behavior comes in. So in my component list, I've got my camera, which is always looking straight down. And from its perspective, it sees the component list that makes up the player. So I've got his movement component, and this is constrained to the XY plane in space. So I've got constrained to plane turned on, and I tell it the normal of the plane. So I know that Z up means that I can move left and right, but I can't move up and down. And then I have snap to plane at start. So I'm going to start everything on the same vertical position so that hopefully my player and my enemies and everything interact with one another. I've then got my default player mesh, which is this little round puck in the center. And that's got the wings attached to it. And the wings are what I call the weapons. So whatever color and shape, that defines which one you currently have selected. And then here we've got things like the camera. And the way I've built this is I have the player center himself, and then I've got scene assets targeted off of that. So if the player moves, it drags these other handles around, and then I can move things relative to that point in space to make sure that everything always lines up. And that's where I do things like the camera and also the sparks that appear in the world. So when you're actually playing the game, there's a star field that you can see which moves as I move, and rather than making a huge one that fills the world, I just create those particles around the player. So as the player moves, he's creating new particles ahead of him. I can also push particles away from the player's origin, and that's all done in Cascade. But it's attached here and turned on and off based on the player's behavior. I also have the reticle, and the reticle by default is invisible, and then as you move it in a direction, the reticle appears and shows you what you're shooting at. So basically, all of this is the setup for how my player is going to act in the world. And then when I actually start the game, I have an event that is, here's the new player. It sets his health back to his maximum. It turns on input. It activates the spark particle in the world and the trail behind the player. So as he moves around, it leaves a streak. It then makes sure that the game state is my little Geo game, and then it gets the player controller and sets that up, and then it starts this regen timer. Timers are fantastic. I use them all over the place because you can start it, you can reset it from anywhere within that blueprint, and it allows you to do something frequently without causing yourself the overhead of having something tick all the time. So it's really useful for doing something like my regen, which is going to happen all the time, but it's not going to happen every second, or it's not going to happen every time the engine updates. So inside of regen, I'm starting the regen loop. I look to see if the player's alive. As long as he is, then I look to see, is he less than maximum health? If he is, add a little bit to it and set that to be his current health until we reach his maximum, and then set the final result to be his health. And this is going to continue to loop unless the player is dead, in which case it's going to just disable the entire timer. And like I said, you can set and clear timers from anywhere, so this gives you a really convenient way of setting something up, let it run until some condition changes, and then clear it and go back to whatever it was you were doing otherwise. So here's where we're taking the X and Y input from the gamepad and making a vector and inputting that as movement as well. So this is taking stick input and also things like mouse and keyboard. Here we have, if you've been hit, we're going to decrement your health. So we're going to basically do the exact opposite of the regen. If that takes your health below 0, you're going to branch and say, hey, I'm going to turn off input. I'm going to call that player dead, which is calling back to that controller, which is here. So the player's dead, so we're going to disable that input. And then back here, we're going to print you died and set the player not being alive inside that GeoGame state that we were referencing before. You'll notice I've got a bunch of different collapse nodes here, I find this is a great way of having a lot of complex behavior that you can kind of easily flip through without actually committing to working through the entire graph. So the wing and weapon orientation, every time there's a rotate weapon event, it looks to see if the stick's moving. If it is, it deactivates the mouse. So we're basically context switching between different input styles. If you're using the mouse, it disables the gamepad. If you're using the gamepad, it disables the mouse. We also take the mouse and stick aim vectors, and if you're using the mouse or the game stick, it uses that, and this is where it sets up the reticle. So essentially, when you move the aiming stick, you are moving an object away from the player in whatever direction you're sticking. I then find that position and rotate towards it, set the reticle to be in that position, and if the reticle is further than a little bit away, we make it become more opaque. So as you push the stick, the reticle comes into view, and the player will orient towards that point, and when we get to the firing stuff, if you've moved far enough, it will fire at the stick, or at the reticle. So here we have, if it's true, if the stick is moving or the left mouse is down, so if we're clicking to fire, we're going to fire the weapon, which is another event inside of my player, and then we're going to ultimately set the rotation of the wings to the reticle, which is what's going on here. We've figured out which direction the reticle is based on the stick movement, and we're orienting towards that. And then here we have, and I'm just kind of progressing through all these things as I encounter them. I wanted the camera to zoom out as you move. So the faster you move, I wanted to essentially be able to see more. So you'd be able to see where you're going and not get blindsided by enemies quite as quickly. So I looked at the velocity and figured, okay, I can take that as some kind of interpolating value between not moving at all and my maximum speed. Given that, I take that as a vector length, which is my maximum velocity will be 600 because that's what I set up in my camera, or in my movement component. And then I created a curve, and that curve value just looks like this. So it's a really simple Bezier curve from 0 to 1 over an intensity of 0 to 1. So I end up using that as a lerp from wherever I started, which 0, so wherever the camera was initially placed, to 400 units away, because that felt like a good distance. Every time Shelly cuts, I'm doing this. I swear, it's like, I'll just do this the whole time while I'm not on camera, and you can trust that that's what's going on. So yeah, I lerp between 0 and 400. I make that the z-vector, and then I set that as the relative location for the player camera. So again, if you're playing the game and start moving, that lerp in and out is being driven by how fast I'm moving and that curve that I defined. And the nice thing with this is if I wanted to plot a different curve, I could change this in any way I want and then just change out that variable and it would work. So going back a bit, so here's where has the mouse been clicked? If it has, then we're going to use the mouse instead of the stick. So the weapon switching, I wanted the on the stick, I wanted the bumpers to be. There you go. On the stick, I wanted the bumpers to switch you back and forth between weapons, and I wanted the weapons to be easily defined. So inside of my weapon switching graph, I have an input action, which is next weapon and previous weapon. All that is defined in the project. I have an input, which is called next weapon, and I told it which keys or behaviors or axes or whatever I wanted. That's what I wanted to be the result of that input. So in my project settings, we have input, which I can't open here because I'm not in the right project. Oh well. But yeah, inside the project settings, I have. I will try to make that the last time I do that. No, I'm not doing that either. Um, Inside of the project settings, we define all of the input mapping. If you want something that is on fire, you can set up a mapping that's named fire and say left mouse button and the A button on a controller, all of that map into that. So then inside of your blueprint behavior, you can just say when on fire is done, get an event. So that's what we're doing with this next and previous weapon here. So here's where we start to get into some of the kind of global mappings. I wanted 4 weapon colors and I wanted 4 enemy colors, and to make sure that those line up with each other. So I have an array of weapon colors which are visible here. So I have red, blue, green, and yellow. I know based on the length of this array how many weapons are available to me. I have a wing list array which basically does the same thing, except that this is 4 static meshes. Each one of these lines up to one of the wing shapes. And then the material reads that wing color, assigns that color to the wing, and when it spawns, that's where it gets things like what particle system color to apply, what wing shape, and things like that. So here I'm looking to see how long is my array, what current weapon am I on, how far am I going to move ahead in weapons. So every time I press that button, it's going to go up or down 1 weapon, and this is controlling which direction it's moving in that array. And then I'm selecting based on am I above 0, or am I below 0, or am I above the maximum. So I'm making sure that it loops within my valid range. And then I say, is my weapon actually ready to switch? If it is, go ahead and switch, but now you're not ready to switch anymore, so you can't do 3 or 4 rapid switches. And then I have a timeline that controls the little animation for what you see when you actually switch weapons. And this is interpolating the color of the trail over time, the little bit of a expand animation. Go ahead and switch, Shelly. You know you want to see me. Yeah, I actually was doing this. A little bit of an expand animation, so it had a little bit of a cartoony feel. And then also the event that occurs. So at some point it's going to say, now it's a valid time to commit to switching the weapons. And then here we have some material behavior and also setting the color for the particle system. So I don't have individual materials set up for all the wings. I don't have multiple particle systems. And what that meant was that I could add as many wings as I want and only have to author the meshes, because every particle system is shared. I just change the color for the different weapons. Every wing is a unique shape, but it receives the exact same material. So all the wings will glow, all the wings will inherit the color of the weapon that they're assigned to, and all of that just works nice and globally as a system rather than having to have a bunch of individual things defined. So the handle gamepad and mouse aiming, this is basically reading all of the inputs for the reticle and setting the vectors that are going to be used inside of the other behaviors. So it's pretty much just get the position of the mouse, convert it into world space, and write that out as a vector, and do essentially the same thing with the gamepad inputs. And thank you, Zach Parrish, for adding the WASD behavior, because I hadn't gotten around to it, and he was kind enough to go in here and add this. So yeah, I have everything kind of laid out so that if something breaks, if I want to increase complexity of behavior, if I want to add something new, I can see where it is all nice and easily. So that's how the player works. Now, the player is obviously only half of it. We need something for the player to fight. So what we have is, for the enemies, I have an enemy spawner and a master enemy, and these are the two most important ones. The enemy spawner is where I handle the individual waves that occur. So this is tracking how many enemies are alive, how many enemies are going to spawn when a new wave begins, and what wave I'm on. So I look to see if we've restarted, and this is setting all the waves to 0, and then it ultimately does reset the waves. The initial setup, however, is we're going to begin cast the game state so that we make sure we're operating with the right set of variables. I'm going to set the number of live enemies to 0, and then I'm going to start a timer that checks to see what wave I'm on. And this is what actually manages the progression from one wave to another. And then there's a timer that looks to see, have we reached the maximum waves, and is it time to restart? So the actual wave progression, every time this timer loops, it executes this wave check, which looks to see, has the number of live enemies reached 0, and are we already ready for a next wave? And then it just indexes, it reads this index and goes, okay, it's time to do this wave, which has a do once, and then begins wave 1. Now, the waves themselves, I didn't collapse so that I could kind of get a really good overview of them quickly. Here we have the first wave. It sets the wave ready to false, so this is kind of my global flag for are we between waves. It sets the number of maximum enemies, which is defined in a variable here, which the first wave is 20, and then it sets the active wave value, basically generates the enemy pool, and then starts the spawn timer, which is here. And again, I use timers a lot. I love them. They are great ways of managing repeating behavior and having kind of a distributed event system. I want these things to all be operating concurrently within a single blueprint. And here we have yes, get player characters unsafe to call in a construction script. Yes, there is a warning in the compile button. In this case, the blueprint's still going to work though. So inside my wave spawner, I have my number of waves, which this is a function I wrote within my blueprint, which is why it looks like that. So I spawn the wave. I say, of my list of enemies, which wave am I currently, and am I at the maximum wave? So here we looked, is the wave ready, or has it completed? And then we spawn actor. And here's where the fun part comes. Inside that wave 1 enemies list are the actual enemies that I'm going to spawn. In this case, I have my master, red, blue, green, and yellow. So if I add more enemies to this, and say, let's go yellow and green, because this list it's reading from that list. It says, how long is the list? How many entries are there? And then it randomly picks from within that list every time it spawns one of these blueprints. So now that I've changed my default list, I will now get some of each of those enemies. I added everything except blue. So that quickly I can define a custom wave. I can add new behavior. I can, if I added new enemies, they would instantly be visible there. And I can have my own little game going. And then just as quickly, if I go into that wave 1 enemies and clear out those 2 new ones, I'm back down to just spawning red enemies, and it goes. So here it looks for a random point in the nav data in that z-plane, and then makes the transform that the spawn actor function uses. So it looks to see where in the world can I spawn one there, and then the enemy's behavior itself takes over. And then inside of my dragged out event graph, I have 3 waves. Now over here on the right, this will be replaced at some point with better documentation, but I have simple steps for how to create your own wave. So if you want to have 5 waves, each with a few enemies, or 1 massive wave, or whatever, I made all of this a little easier to parse by adding instructions. And that is the basics of how the enemy spawner happens. There's one placed in the world, and then inside of it, I'm not even defining anything. It just needs to be in the world. And then we come to the enemies themselves. So inside of the enemy behavior, I have a component which is the actual collision primitive. I have a rotation handle because I want to be able to move it, and then the enemies have behavior where they can tumble if you opt in for it, but I didn't want that to actually change the trajectory of the enemy. I wanted it to be differentiated between. And then I have the actual shape of the enemy which is just a static mesh. And this is the torus mesh from the starter content, or from the shapes. So in the graph, in my construction script, yes, you cannot autosave, go away. In the construction script, I have how fast is this enemy allowed to move, what is the movement component that I'm affecting here, and then it creates the material behavior so that each enemy can be a different color and things like that, and those get set here. I also have the enemy mesh, which gets set, and then inside of the event graph, I've been talking for a long time. So we have the begin play, which just like in everything else, it's my setup. I'm setting up a couple of timers. I'm getting the game state, and then the enemy talks to the game state. So this is how I track the number of live enemies. For every enemy that is spawned, it increments the live enemies count by 1. For every enemy that dies, it decrements it by 1. So this is my kind of internal exchange. I want the game state to know about all my enemies so that any other blueprint can just get the game state, ask it what's going on, and derive from that. So if I wanted to have a boss enemy that only spawned when the number of live enemies reached some value, I could do that this way as well. And so again, I'm setting up timers, and this is all part of my initial creation. So is it spinning? This is how it tracks and follows the player. And then we set a random vector. And this random vector is used elsewhere to define how we're going to move. And like I said, I've got the optional ability to spin. So if this Boolean is set to true, I will add some rotation every frame. And this is where that random vector comes into play, so that I tumble in a different way for every enemy that gets spawned. Again, I dropped in some simple documentation so that when you open this up and look at it, you can kind of see how it's in play, how it's working. But again, I've color-coded and kind of tried to self-document as much as possible. There's a bit of color coding, so red is damage, black is death, green is birth, yellow is vector-based stuff like finding a direction, things like that. And I tried to keep that true for most of this stuff. So here's where, when I'm trying to find the player, I have a loop that basically constantly gets the player's location here and my location, and works out the rotation to face the player. So whatever direction the enemy needs to move to get to the player. And then that's biased by the actual speed that the enemy can move. So he can't do 180-degree turns in a single tick. He has to actually follow a curve to get to the player. And that's expressed inside of the movement. So every time follow loops through, it says, here's the velocity I need based on if the player's alive and the destination value that gets set when it actually does find the player. It then says, okay, I'm going to set my velocity to that value as long as the player's alive. And that's how we do tracking to find the player and move towards him. If I wanted to, I could easily set up things that check to see if the distance from the player to the enemy fell below a certain threshold. I could stop it and trigger another behavior. So if he had a weapon that would only fire if he was within a certain range, you could say, here's the range. Is the distance from the enemy to the player closer than that? And if it is, fire or explode, teleport, any kind of behavior you want at that point. All of that is already, the data is already there. It's just a matter of coercing it to find whether or not you're satisfying some condition. And here we have, if the enemy overlaps the player, I didn't want to use collision because I was having some issues with colliding with the ground and things like that. So I decided to use overlap fairly early. When it overlaps with something, is it the player? If it is, one time only, damage the player, and then here it just kills itself. It cleans itself up quite effectively. So it turns off all the timers, it disables all collision, it spawns the death particle system here. It also looks at the color, which is reading from part of the setup is defining what color is the enemy. and then it sets that in the particle system, spawns the particle system, and then calls the cleanup. So I'm removing myself from the pool of live enemies, and then I'm destroying myself. And that, in a nutshell, is how the enemy is set up. And then I just created the sub-enemies based off of that. So if I want to create a new enemy, I can create a blueprint based on this and say, in the defaults, I want to change the mesh to something else. So we'll find some random mesh, and we'll set that to be his enemy shape. And we can also set things like what color this enemy is going to be, and so on. And then now that I've created this guy, if I go back into my enemy spawner, inside of my waves, inside of the, say, wave 1 spawner, I can go into that wave 1 enemy list and expand this out a bit so I can actually see. And now I have my BP enemy master child, and when I play, there's my new enemy, who, because I haven't defined his own unique color yet, is essentially a red enemy. But one of the things that the master enemy has defined differently than the red enemy is his health. So if I go in and set his health to be 250, not 2005. Keyboards, I've never used them before in my life. Don't laugh at me. All right. So now I've set my new blue enemy to be susceptible to the red weapon, but he's going to be extremely hard to kill because he's got so much more health. So as I progress through, you'll see I'll end up with mostly the blue ones because they last quite a bit longer. And if I stop and let them kill me, I go to game over. I get my player health decrementing down to 0. Now, I used UMG to the HUD. It was actually my first foray into UMG. And here, I'm basically doing the same thing I did in UMG for the behavior that you saw. Here we go. So I'm reading from the game state. A lot of these values are set based on that, and then I just look to see, is the player alive, is the player dead, and then I have values for current wave and things like that. And yes, this I know has a compile issue because the WASD behavior necessitates an update to my HUD, which will hopefully be done before this actually goes public, or any more public than it is now. So again, I'm getting the game state. I'm making sure that it's the Geo game state. I'm looking to see what the active wave is. And then I'm then converting that to a text, and then I'm returning that. And so that comes into my my wave value here. So this is bound to that function, my here, current wave. So this one element of my HUD is reading from the game state to see what the wave is, and a lot of this is driven the same way. The health bar here looks at the player's actual health. It's reading it from the game state. I'm pushing it up to that every time. The win or lose state is driven by whether or not you were killed or whether the final enemy was killed. For a while I had some interesting things where you could both die and win at the same time, and all of that would come on nice and inconveniently. Let's see. That's the bones of everything I did. We showed this off a bit at EGX this year. Put together kind of a 15-minute version of how to do all this, how to create your own behavior. A lot of the other parts, for example, inside of the particle system, so here's the player. Player has particles. He has a trail, and if I turn on motion, you can see that. So that's his trail. It's got a little bit of noise to it, and a GPU particle system that spawns behind based on, a CPU particle system that spawns behind based on how fast he's going. So the faster he's moving, the more little dots he leaves behind. I did it as a CPU particle so that it would work on iOS. There's no support for GPU particles on most, if not all, mobile devices currently. So it made a lot more sense to do something in CPU rather than GPU because I wanted it to be a little more multi-platform. There are a few GPU particle systems, notably on the enemies, that I wanted to switch based on what platform, but for the player, I figure it was made more sense for me to set it up in the most common use case scenario and then modify it later. Inside of these, they have an initial color module, which defines a parameter, and then this is how I'm pushing what color the player's weapon is and wings. This is how I'm reading that data. And then I added a little bit of noise to the ribbon so that as the player moves around in the scene, it's not just a constant red or whatever color ribbon. You'd actually see a little bit of interesting breakup to it from time to time. So those are the basics of everything I built. I'm happy to answer questions. I've got a couple that came directly from the forum. Some of it I've touched a little bit on. The first is, how would I go about having the player face the direction they're attacking instead of the direction I'm moving? And again, that's how I'm doing this. I have the player's movement is divorced from his orientation. So I'm moving one object that you never see around. The player, as the end result is perceived, is essentially on a swivel on top of that. The direction it's oriented is based on the other stick, or in this case, the mouse. So the player's movement is very acceleration and vector based, but his rotation is a completely separate thing. And I did that by, in the player's blueprint, if I can find it, here we go. In his components, I've got his movement component, and that's what's driving his actual movement in the world. But then everything is set to being driven off of puck and wings, and those do not use the same rotation value. So I have a pre-rotate that gives me the correct orientation, and then all of these values are being driven independently of the rotation. So it's basically, I have hinges in place that let me orient him independently of his motion. So how would I create attacks with different ranges, sizes, and spreads? Right now, when you actually fire a weapon, and this actually does cover something I didn't touch on, the weapons themselves. So I created a particle projectile. And when you pull the trigger, if everything is true and you're allowed to, it spawns one of these based on your wing or weapon orientation. There's a projectile behavior node or component in here that gives you things like whether or not it's on a plane. It's very similar to the regular movement component. And then I have it set to bounce and things like that. And then it has a particle component, which is the main visual element. I also have a projectile light so that I have a little bit of a glow if it gets near a wall or a player or another enemy. Inside the behavior, I have my initial setup, which plays the sound, turns on the particle systems for the weapon. I have what happens to hit something. I'd actually set it up so that enemies could fire projectiles as well. It just turned out to be too many things going on screen at once for what I was trying to show people. So I have it set up that if it hits the player, then it does one thing. Otherwise, it does another. So if it hits the player and the object is cast as the player correctly, it applies damage to the player. Otherwise, it hits whatever enemy it touched, in this case the other actor, and then it turns itself off and goes away. Now, this works wonderfully for a single projectile. It would also work just fine for multiple. Instead of spawning a single class that did 3 projectiles, I would just spawn 3 projectiles simultaneously going in different directions, whether that's by adding a bit of random rotation, or having some kind of array of vectors based off of the initial rotation. You could set that up pretty quickly to, say, upgrade your weapon or have a special behavior because of having just respawned or something like that. And so that you would do inside the player himself. You just spawn X number of projectiles. You can also easily create projectile blueprints off of this and have more projectiles in a single blueprint. But I tend to lean towards making global systems rather than doing a lot of special case one-shot effects like that. So I like to have the ability to have a bunch of things leveraging one amount of work that I've done so that I can do things rapidly once I've done the setup. So the other question I've got here is, how can I get enemies to approach the player but stop when they're close enough to attack, whether it's melee or projectile? And I did touch on that a little bit. Again, because the way the enemy follows the player, he essentially always knows where the player is and how far away. He just changes his velocity and direction based on where he thinks the player is going. So if you then took that same data and said, I've fallen below some threshold, say 200 units, you could then have a completely different branch of behavior occur at that point. You could start a timer that says, now fire at the player, and every X seconds or tenths of a second or whatever, it would take a pot shot at the player. And you could easily just take the player's current position as your vector to fire along. Now, the enemies that I created in here don't have any turrets or any kind of directional behavior. They just float around and chase the player down and try to hurt him. But it would be pretty easy to just ping the player, find out where he is, and lob a projectile in his direction. The same would be true for melee attack or a long-range shot or whatever. It could get more complicated if you decided you wanted to do things like predicting the player's direction of travel, which means you'd need to have not only the player's current vector, but say his previous vector from 0.2 of a second ago, and extrapolate based on that. You know, he's here, he was here, so this is a line, so he'll probably be here if he's continuing along the same direction. And then you could fire it where you think his new direction would be, so you could lead him a bit. It wouldn't be very hard to implement. I'm not going to do it right this moment, but that's essentially how I would do interactive behavior between the player and the enemy, other than just collide and crash into one another and die. I love how I've gone over every single thing I had in slightly less than 45 minutes of an hour-and-a-half stream. So, any questions? I'm happy to answer anything about what I've shown and try to answer other questions if anybody has anything. If not, I'll make sure that I'm mocked heartily. I'm supposed to stretch. Stretch. Yeah, I don't know what to stretch to.
Just while they come up with questions.
I'm sorry?
Just while they're coming up with questions.
Just while they're coming. Does anybody have any questions about Unreal Engine in general that I can answer? Last time I danced on camera, it was not good. Well, I was mocked for it, which is fine. I love being mocked. So somebody asked, what's the best way to handle selecting one projectile out of multiple choices? That depends. If they're all the same class, then you could do things like randomly selecting one by getting all objects of a certain class. If you have something like a spawn manager, like I have for my enemies, then you could say add them all to an array and then pick out of the array. Or you could do something like give me the closest one. Do a really quick calculation of distance from each player to me, which would be pretty easy. You just write, have each enemy write into the game state their distance and their ID, and whichever one is the lowest one is the only one that you keep, and then you just retrieve that one and act on that one. Why is UE4 so awesome? Hopefully because we've done a really good job of putting together powerful tools and showing people how to use them. How are the level bounds set up? There's no actual like predefined bounds. There is a massive plane, basically. It's untessellated. It's just a massive quad with a world projected material applied. So, as a matter of fact, it might not even be, yeah, it's world projected. As I move it, it doesn't do anything. The material itself is only slightly complicated. Ignore the massive glow. So I have a world position and a scale that I use to derive a sine wave. So that gives me this shape, and you can kind of see where this is going. This ends up becoming my overall grid. So I wanted to combine these down in a certain way. And then I have an overload value that brightens up parts of it. So I wanted the center to be a little brighter than the outer edge. I should really turn off autosave at some point. Yes, go away. Thank you. And then I ultimately have a color that gets modulated in, and that becomes the end result, which is massively, massively bright. But then once it's placed in the world, I have a material instance which allows me to control the thickness and overload value. So the overload is just giving me, given the current color, what should I drive it at? And then the thickness is how thick the actual grid is. So as I make these changes, you can see how that's applying to the materials in my scene. And then there's a second material instance for the one below, so that if I made a change to the one the player was centered on, it wouldn't necessarily interfere with the one below me. So there's a lower grid material as well. Can you see the camera settings again? The camera settings for the player, I assume you're talking about. So going into the player's blueprint. So we start off with a just default camera component facing down. I oriented it so that up relative to the controller was the top of the screen. There's not really anything complicated going on here, except that I've modified the aspect, or the fact that the aspect ratio is constrained. The control comes in that the camera has a root component, which is a child of the player, and this is how I can move the player to and from, move the camera to and from 0. So the camera's position relative to its parent is 0. Anytime you move the player or move the camera, you're just moving it in space relative to that point. So you can see right here the location zeroed out. If I drag it over here, I get a non-zero value, but it's not very high, even though it's quite a ways from the origin. And then inside of the player's graph, we have a where's the camera behavior? Wow, I just showed it and I can't remember. Should be in wing weapon. Orientation. Here we are. Camera zoom behavior. Given there's a maximum velocity for the player based on his movement component, if I'm dividing by whatever that maximum is. I could do it by getting his movement controller, getting the maximum value and dividing by that, but I set it up as a static value here. This basically gives me the lerp value from 0 to 1, and then I evaluate the curve that I created based on that, and that's my offset from that root component for the camera. So the faster you are, the closer you are to the maximum acceleration value, the further your camera will be away, up to 4 units away from its origin point in the world. Are the enemies using movement components? Yes, they are. I'm updating their velocity vector frequently to align to the player. So inside of the master enemy, there's a movement component here, which has, it's actually a projectile because I wanted to be able to have them bounce off of things. But their velocity is being set every frame, well, not every frame, but every time they successfully find the player. And that's done here. So there's a tracking event that gets triggered repeatedly. It finds the player, works out. This little bit of vector math is pretty useful. I'm ignoring the Z component because I know that up and down relative to the camera are useless because I'm doing everything on the 0 plane Z. So I get my location and the players, and then I end up working out, subtracting the player's vector from mine, which gives me the difference between my location and where the player is. Using the make rotation from X and then rotating along my movement speed, which is the velocity. This gives you a non-zero length vector from me towards the player. Because I wanted, the reason I didn't use get direction vector was because I wanted it to be scaled based on its movement speed. I basically wanted, at one point I had him so that the further away from the player he was, the faster he would move, which really wasn't. Basically all the enemies would warp into view and then attack the player. So this was the end result of how I did it. One of the really, really powerful things about blueprints is that you can approach a problem from multiple angles and find a solution that fits your particular development or design style. So can you show us an enemy that shoots back? I can probably create one in a few minutes. So let me grab this and move the whole behavior tree out a little bit so I can get into it. So the first thing I would do is set a timer of fire at player. Give it a 0.2. Yeah, let's change it to 1. So there's a 1 second loop of if it does find the player, will it take the shot? And then I'm going to add a branch that says, are we going to allow has weapon? So if has weapon is true, then we will execute this timer. And we also need to remember to clear this timer at the end. Oops, because we don't want to have him trying to fire at the player when the creature or when the enemy or the player is dead. I'll just put this in the end right before we destroy the actor, because why not? So now we will custom event, fire at player. Spawn an actor from a class, and we're just going to choose. Let's create a new projectile and make sure that it's not a player projectile. Enemy projectile. I have no idea if this is going to work, by the way. It's been a little while since I've played around in here, and could very conceivably be doing something wrong. So now I have a enemy projectile that has the enemy projectile flag turned on. So now it considers itself to be coming from an enemy in terms of what to do when it hits something. So in the master enemy, we're going to pick the enemy projectile, which now that I've created that essentially as a class by creating a blueprint from the other one, it gives me all of these values. We'll change the weapon color to be blue, why not? And then we will get direction vector. Let's just try this. This we may not need. Anything more than this. So let's get the world transform for myself. And then let's go into one of the player or one of the enemies, and in my relatively newly created child, I'm going to find the has weapon checkbox, and who knows if this is going to work. So now they should be firing at me all the time, though who knows if this is actually going to work. Well, they're firing at something. And you can see when they hit me, but my velocity or my direction isn't right. So inside of my master enemy, I'm going to get the location of myself, and let's see, I'm going to want we'll make a rotation from this and see if this works. It's fun watching me type, isn't it? I do a lot of it.
I haven't put the monkey up yet.
I'm funner than all my non-friends.
Funner.
I have no friends.
Funner.
I'm funner.
Funner.
It is a worder. It's a worder. I'm just going to put ER on the end of everything. Hey, look, my enemies are now firing at me all the time. I'm gonna die. So there's an enemy that shoots back. You can see, because I built it as a system, it was really pretty easy. and the enemies don't know that I'm dead, so they're not firing correctly, or they're continuing to fire, because I didn't stop the timer. So everything I just did was essentially leveraging things I had already created, right? I'd already made a projectile, I'd made the enemies. But because I did them as systems rather than as just one-shots, it was pretty trivial to add something in the base class, the master enemy, and then expose that in subsequent children of that class. And that's one of the things that I enjoy doing a lot, especially with blueprints, is the ability to say, here's a system in place rather than a single thing. Here's a utility that you can use, you can adapt to use in other ways. So let me go looking through here, see if I find any other questions. Do we have any other questions that I missed that could be up on this nice little document on the side? I'm getting I don't know. I don't know.
I don't make the list.
I have a machine gun auto firing on a timer. It feels inconsistent. What can I do to stabilize it? I have absolutely no idea. Unfortunately, for something like that, there could be a lot of variables in play. Without looking at the whole thing, it'd be pretty hard to debug a particular result or why not you're getting that. I'm looking for questions. You're not throwing a monkey on me. I'm not getting a monkey. I have no idea what the monkey. What would be the best way of making a game like that wrap around? If the player moves far to the right in example, so the game looks limitless or without bounds. That can be really hard. It depends on how you're handling movement. It's pretty easy to say, I have bounds of, say, negative 500 or positive 500 in a given vector. And say, if I move above 500, subtract 1,000 and update me. So, right, the entire range of negative 5 to positive 500 is 1,000. So if I go to 501 and I subtract 1,000, I'll be at negative 499. So I'll have essentially teleported across. There's a few things that might not update correctly when you do that, because they will take that move as an actual movement. I move between these two places in one frame. So you'd want to have special case behavior for things like particle systems and things like that. There's a couple of things that you could do to kind of hack around that. The brute force method would be have tiles of the player in each location, and you teleport to the player and move the other ones back. So you're basically looking at an active one, but you're keeping the other ones in sync, and then changing the active one and kind of hopscotching those around. That would be, as I said, a brute force method. You could probably get away with it for prototyping, but it wouldn't be how you'd want to do it as a final shipping element. The problem with then is you have to track not only the player, but enemies as well. Now, one of the things that you could do pretty easily is make sure that your enemies always spawn within a certain radius of the player, and if they exceed that radius, they get recycled. So you basically have a moving bubble of active enemies. If the enemy falls outside for over a certain period of time, whether it's a second or 5 seconds, 10 seconds, whatever, he goes back into the pool to be recycled. It doesn't decrement from the live enemies. It just says, I need to find a new location, move there, so that he's a valid target for the player. That way you don't end up with this massive field of enemies because you're getting teleported around and they're adjusting to come back at you. You would have other issues with things like I said, particle systems. Velocities might get updated a little oddly during the teleport, but most of that stuff would auto-resolve within a few frames. The biggest problem I think you'd have is the visual glitches as you teleport objects around. But again, I think that a lot of careful distance-based tracking for your projectiles, the enemy's projectiles, things like that, to make sure that you have a very large world, but you don't end up simulating things that are a very large distance away from the player, so that you kind of keep the action and any cost to what you have going on where it does the most good, around the player. Gameplay blueprint uses, like what does what, like game mode. Well, we use game mode and game state for different things. Like I'm using game state here as a kind of global tracker for the world, so that I can, every blueprint can get and talk to the game state. So I created a game state, I populated it with some variables, and then my individual blueprints can talk to that, so that my player can ask the game state how many enemies are alive if he needs to. The enemies can ask the player things, how much ammo do you have, how much health do you have, things like that, if need be. I also use that so that the HUD has a convenient place to grab all this data without having to call functions on things like the player or enemies, so that everything gets the right set of data in as timely a fashion as possible. How about constrained to a cylinder, surface, or sphere in order to make a boundless world? You could try that. The problem there would be you'd have to do quite a bit of work for something like physics to make sure, because you'd end up writing your own constraint system to some degree to make sure that the camera and controls always looked like, if I push up, it's going to move up. I'm not going to end up in some weird gimbal lock situation where I'm now, no matter what direction I push, I'm spinning or something like that. Somebody asked if it's not a feature of the UE4 engine scene graph. If you're talking about the constraining to cylinder or sphere, no, there's no built-in physics mode that says view a single point with a radius as a gravity source or an alignment source. How multiplayer friendly is this project? I have no idea. I didn't build it with multiplayer in mind. You'd want to replicate the behavior of the enemies, the behavior of the player, and also the game state, but I haven't looked into what would be necessary to do that. I was looking more at if you were going to prototype building a twin stick shooter and what kind of systems needed to be in place for you to build that and have it all work. UE4 general question, what about splash screen? I have no idea. That's outside of the kind of stuff I do day to day. Yes, autosaving, fantastic. So somebody pointed out that you could spin the cylinder, not the player. That's very true, though in any case, your frame of reference becomes important, because you don't want, it would look great if you had just the cylinder moving and the player static. Problem is, what about the enemies? They need to be in the reference frame of the cylinder, not the world at that point, because otherwise cylinder spins, enemies here, cylinder spins onto the enemy appears to be ignoring the orientation of what you're doing, they just come and get you in the middle. So you'd have to, you'd still have to work out the transform to sweep them around the cylinder so that they're continuing to traverse towards you rather than being in some weird screen space orientation and coming right at you. There's a lot of discussion about how to do stuff like that. There are probably almost as many ways to solve that problem as there are implementations you could think of to use that kind of behavior. There have been a number of games in the past, both in Unreal Engine and otherwise, that have done unusual physics models, and it's always something that's a challenge to accomplish because of the complexity of control when you start to change camera orientation and gravity and things like that. I'm just sitting here. Oh.
There you go. He's my time filler.
I'm
He's gone. He's gone.
I'm monkeyless. I guess I had to get the monkey. I haven't in the other whole one Twitch stream I've been a part of, there was no monkey.
He comes out when it's quiet.
The monkey comes out when it's quiet. So I don't know that. Does anybody else have any questions? I've been doing Unreal Engine stuff for a long time. I can take a stab at non-engineering, only art related. Or can you sit it on my shoulder?
With the monkey?
I assume so.
Oh boy.
I can't believe I'm sitting here waiting for you to put a monkey on my shoulder.
There you go.
Wow. Yes, I have a monkey on my shoulder. Aren't I cool?
See.
There. I cracked the monkey off my shoulder. um,
Just tell people to put questions in the forums if they think of anything.
yeah, if you think of anything, feel free to post them in the forums. We'll make sure that somebody sees them and answers them in as timely manner as we can. I'd like to thank everybody for coming and watching. This is something that I started just for fun because I wanted something to be able to demonstrate to people. Kind of one of the things that Blueprints does is it shows other people how you think, because the way people structure things is almost as identifying as their artwork or in some cases just a conversation, because the how your brain structures things is going to show up in your blueprint. So thank you very much for checking it out. It got too quiet. I had no choice. You had a choice. Like I said, thank you very much for sitting in and watching it. People had some really good questions. I'm glad I could answer some of them. Hopefully, there was useful information in this for everyone, and I look forward to doing this again somewhat soon. Bye.